Is it inaudible, please, all of you? Fine. So let us understand today what we're going to be discussing. First, let us fix a agenda. Let us fix our agenda, guys, please. Let us fix our agenda, guys, please. So today, our agenda is what exactly? What is DevOps we're going to be discussing? What is AWS also we're going to be discussing? By end of this, by end of this, by end of this, we can conclude what is a major difference between AWS versus DevOps. What is the relation between these two also? We're gonna be understand by end of this session. And before starts, let it be introduce myself. My name is Maha. I have totally 15 years of IT experience. My career starts with Java developer. And then I turn as a DevOps engineer. From last 5 years onwards, I'm working as a senior DevOps engineer. It is include AWS and Azure also. That is in exactly my profile. Yeah. So before starts, I want to discuss with about these three questions. I want to discuss about these three questions. I want to come to know. So what is the first question, please? What is an application? Second question, what is a server? Third question, what is an SDLC? So what is the first one, guys, please? Application. What is an application? The working software which is written any programming language, we calling as an application. We calling as what? Application. We calling as what? Application. I'll repeat, what is an application? The working software which is written any programming language, we call as an application. That application we're gonna be placed on server side. Once if it is placed on server side, we can access our internet as a Flipkart or Amazon Book My Show. Is it clear? So what about SDLC? SDLC is a software development lifecycle. By using SDLC, we can able to produce an application for doing a business in internet like Flipkart or Amazon, Book My Show. Book My Show. In this SDLC process, we have analysis, design, implementation, testing, deploy, and maintenance. By following these are all the stages. By Following these are all the stages, we can able to produce an application. Yeah, please continue. So in this in this SDLC process, we have analysis, design, implementation, testing, deploy, and maintenance. This entire process, which we are calling as what? SDLC, software development lifecycle. So by using this SDLC process, by following these all the stages, we can produce an application like Flipkart, and we can able to do business on internet. In internet, guys, please. In internet, guys, please. In internet. For example, if you want to build a Flipkart kind of application, a Redbus kind of application, what I need to do, please, first we need to analysis. Means what? Gathering information from the client, how exactly the login page, how exactly the registration page, each and everything will be gathered based on gathering information. Based on gathering information. So our architects will be design. Design is nothing but what? Plan. So once if it is designed, our developers will implement the lines of code by using Java, .NET, Python, by using any programming language. Our developers will implement the lines of code. Once if it is an implement, okay, we're gonna be in execute a test cases. We're gonna be executing our test cases. Which are all the test cases? Maybe performance test cases, functional test cases, whatever manual test cases, whatever we can execute and verify our application. Once if it is verify the functional level, we're gonna be deploying our application on hundreds of servers. Then only we can access our internet as a website like Flipkart or Amazon. Whether it is working or not, whether it is gonna be working or not, we're gonna be monitor and maintenance. Monitor and maintenance. This entire process which you are calling as what? Software development lifecycle. In this SDLC process, if you are a software engineer, what exactly we are here? Okay. If you are a developer, can write the lines of code. If you are a tester, can verify the functionality. But if you are a DevOps engineer, how exactly? If you are a DevOps engineer, what exactly? What is a DevOps, please? First, let us understand. So DEV is nothing but what? Software development. OPS is nothing but what? Operation. The combination of software development plus operation is nothing but what? DevOps. Is nothing but what? DevOps. So that means what? The combination of here software development plus operation, we call as what? That means our roles and responsibilities. Our roles and responsibilities start from dev environment, ends with what? Operations. Ends with what? Operations. So that means we are a part of coding, build, test, release, deploy, operation, and monitor. To be frankly, we are not writing any coding. We are not writing any test cases. Just we are going to be in implementing an automated process. An automated process, yes, please. An automated DevOps transparent pipeline, which we are going to be implementing. Tell me, is DevOps is a technology? Is DevOps is a technology like Java, .NET, Python? No, DevOps is not a technology. DevOps is not a technology. DevOps is a process. DevOps is a process. DevOps is a process. An automated process which we are going to be implementing from dev environment to operations. Dev environment to operations. But usually how exactly we can implement this process? For example, the developers are keep on writing the lines of code. These lines of code we're going to be delivering into the production environment within a shortest time with high quality, with low cost is nothing but what? Our DevOps transparent pipeline. So as a DevOps engineer, our roles and responsibilities, going to be delivering into production environment within a shortest time with high quality, with low cost is nothing but what? Our DevOps transparent pipeline. As a DevOps engineer, what exactly we're gonna be, guys, please, we're gonna be replacing with what? A complex pipeline with what? Transparent pipeline. A complex pipeline with what? A transparent pipeline. So what is an exactly complex pipeline? What is an exactly transparent pipeline? The complex pipeline is nothing but what? Our SDLC process. The software development life cycle. The software development life cycle. We are calling as what? Complex pipeline. Sir, why we are calling SDLC as a complex? Because of it is a manual process. Because of it is a manual process from analysis to design, design to implementation, implementation testing, testing to deploy, deploy to maintenance. It is a manual process. It is a manual process. Due to this manual process, in middle of the process, if you got an error, any issue in middle of the process, any problem, any issue, it is very difficult to identify. It is very difficult to rectify. It will take a long time to identify. It will take long time to resolve. If it is take long time, definitely cost will be increased, the quality will be decreased. So we are not using this flow. We are gonna be replacing with what? A DevOps a transparent pipeline. DevOps transparent pipeline. DevOps a transparent pipeline from dev environment to operations. Dev environment to operations. While we implementing this in automated process, okay, even though if you got an issue in the middle of the process, even though if you are getting error middle of the process, very easily we can able to identify, very easily we can able to rectify the process, we rectify the problem, and we can able to deliver as soon as possible. If we can able to deliver as soon as possible within a timeline, definitely we want that. Means in this process, everything is an automatic, everything a transfer. That means what? Cost is reduced, the quality will be increased. So definitely we want this feature in our application. So that's the reason we're going to be replacing with what? Complex pipeline with what? Transparent pipeline. But actual DevOps transparent pipeline is look like this only. In this DevOps transparent pipeline, so we have a plan, coding, integration, testing, release, deploy, and operations. And Operations. So our roles and responsibilities start from dev environment, ends with what? Operation. That means we are part of coding, integration, testing, release, deploy, and operations. And operation. But to be frankly, we are not writing any coding. We are not writing any test cases. We are not doing any planning also. Just we are gonna be implementing an automated DevOps transparent pipeline from dev environment to operations. So that is only reason we are part of coding, integration, testing, release, deploy, operation. But in this DevOps transparent pipeline, what is in it? How exactly we are involving here? What is the roles and responsibilities? Let us understand step by step and stage by stage. So as a DevOps engineer, as we discussed, roles and responsibilities start from here, ends with here. But let us start from planning. Are we part of planning? No. Are we part of coding? Yes. But how exactly? Writing lines of code is by developer, not by you. Writing lines of code by writing lines of code by developer, but not by you. Once if it is written, the number of lines of code, it's gonna be maintaining by DevOps engineer. Writing by developer, maintenance by DevOps engineer. So how exactly we can maintain these all the lines of code in a source control, in a version wide, in a Git, in a branch wise. So once if it is maintained, we're gonna be integrating all developer lines of code. We're gonna be integrating all our developers lines of code. Once if it is integrated continuously, whether this software is working or not, we're gonna be execute our test cases, which is written by developer, not by you. Sorry, which is written by testers. So the test cases just we are including in this process. So once if it is verified, we're gonna be delivering into the release, continuously delivering into the release. Okay. But whenever execute test case, if you got an error, automatically it is redirecting back to the developer. Developer has to fix an issue, again integration, again execute. Again error, again get back to the developer. Developer has to fix an issue, integration, again test. So this loop will be repeated until zero errors. Once if it is zero errors only, it will be delivering into the release. Once if it is delivering into the release, we're going to be deploying our application. We're going to be deploying our applications on hundreds of servers. Once if it is deploying on hundreds of servers, we can access our internet as a website like Flipkart or Amazon, book my show. Once if it is done, then whether this is working or not, this application is working or not, we're gonna be verified. So this entire process, which we are calling as what? Our DevOps transparent pipeline. But for implementing this DevOps transparent pipeline, we're gonna be using some tools like which are all the tools we're gonna be? Which are all the tools? Git we are gonna be using. Git we are gonna be using. Maven, Jenkins, JFrog, SonarQube, Ansible, Chef, Amazon, Docker, Kubernetes, Vagrant, Negios, Elk, ELK, Elastic, Logstack, Kibana, Terraform. So these are all the tools we are going to be using for implementing our DevOps transparent pipeline. So each and every tool, we're going to be learning in depth. Each and every tool, we are going to be learning in depth. So we're going to be do practical each and every tool. And we're going to be do projects also. But how exactly we are going to be using these are all the tools that let us understand right now. Git is a version control. Git is a version control. So whatever the lines of code is written by developer, it's going to be saving into the Git. Git is a version control. Once if it is maintained in a Git, each and every lines of code, we are going to be an execute. Build Maven is a build tool. By using Maven, we can able to build our projects. It is always generate an Octave factory. So whether it is Git and Maven, we are going to be using Jenkins for automation. Jenkins is a continuous integration, continuous delivery, and automation tool. By helping of Jenkins, we can able to implement our entire CI/CD process with the continuous integration, a continuous delivery, continuous integration, continuous delivery, CI/CD process. And once we delivering, where to deliver continuously into the JFrog. JFrog is a release. JFrog is a release. And SonarQube is a code analyzer, whether the developers are writing with standard or not, whether the developers are following right functions or not. It will be very fun to give statistics by helping of Git, Maven, Jenkins, JFrog. SonarQube, we are gonna be implementing our CI/CD process, continuous integration, making working software, and continuous delivery. This entire process, which we are calling as what? CI/CD. CI. CI/CD. CI/CD. Continuous integration, continuous delivery. But once if it is delivered, then how exactly we can? So we're going to be deploying our applications on hundreds of servers, am I right? These hundreds of servers, how exactly we can automate? By helping of configuration management. So by helping of configuration management, we're going to be replacing with what? Manual process with what? An automated process on a hundreds of servers at a time. So for this, we are going to be using Ansible. Ansible is a push model, and we're going to be learning Chef. Chef is a push model. One push model, one pull model. We're going to be learning for automating of our hundreds of servers at a time. And these hundreds of servers from where exactly we can able to get it from AWS. So by using AWS, we can able to get a hundreds of servers. These hundreds of servers we can automate by helping of Ansible and Chef. Not only placing our applications on AWS, we can able to place our websites on Docker container also. What is a Docker container? Docker container is an isolated area which you can place our websites very easily. These Docker containers we can automate, we can orchestrate and control and manage by Kubernetes. And Vagrant is a virtual provisioning tool. Negios is system monitoring. We can able to monitor our service, whether it is down or up. We are gonna be monitored. Clear or not? And ELK, Elastic Logstack Kibana. By helping of ELK, we can able to monitor applications. And Terraform is a cross cloud platform. By using Terraform, we can create servers in anywhere. Infrastructure, we can able to create any cloud, either AWS or Azure, Google. By helping of these are all the tools: Git, Maven, Jenkins, JFrog, SonarQube, Ansible, Chef, AWS, Docker, Kubernetes, Vagrant, Negios, Elk, and Terraform. We can able to implement an automated DevOps transparent pipeline. An automated DevOps transparent pipeline. Clear all of you? Is it perfect all of you? But while implementing this DevOps transparent pipeline, we required one more thing. While implementing this DevOps transparent pipeline, we required infrastructure also. So, but what is infrastructure? But tell me, what is an application? What is an exactly application? Anybody? Application is nothing but a website. Am I right? As we discussed in the beginning, application is nothing but what? Website, like Flipkart or Amazon, whatever, Flipkart or Amazon, whatever may be. Is it clear? So the working software, which is written any programming language, we call as an application. That application we're going to be placed on server side, then we can access over internet. Agreed. But but what about infrastructure? For maintaining these websites, for maintaining our applications, what kind of infrastructure we require? Majorly, servers are required, networks are required, database is required, storage is required, and so on. These are all major infrastructure is required for deploying our websites. But question is, how many ways we can able to get this infrastructure? How many ways to get infra? So we can able to get it either physical environment, virtual environment, or from cloud. And what is cloud computing? What is cloud computing? First, let us understand before understanding what is a data center. The huge computing power keeping in a rack wise. The huge computing power keeping in a rack wise in a big room. We calling it as data center. These data centers are located in different geographical locations. Different geographical locations like in Chennai, Hyderabad, US, Sydney, South Africa, Singapore. In so many places, these data centers are located. Clear or not, please? Understood, it's very clear. On top of this, on top of this, on top of this infrastructure, we're going to be placing our application. So for deploying our applications, what kind of infrastructure required? Either we can able to get it physical environment, virtual environment, cloud environment. But we are going to be getting from cloud, on top of the cloud infrastructure, we're gonna be place our websites very easily. Very easily. But let us understand a little bit deeper what is the cloud computing. What is in exactly the cloud computing? Let us understand, guys, please. So if you can access, if you can access, if you can access whatever the resources from this data center over internet from a laptop is nothing but what? Cloud computing. What are the cloud computing is, please? Remote placed resources such as server, network, storage, database. If you can access over internet from your laptop is nothing but what? Our cloud computing. Our cloud computing is, please. But any cloud is a rental based infrastructure. Based on usage, we're gonna be pay rent. Based on usage, we are gonna be pay rent. So we are not buying. We are not buying. Just we are gonna be getting service, whatever the service you wanted. Based on usage, we're gonna be paying rent. It is just like a Ola, Uber, or cab, Rapido. So you want to go to railway station from your home, just to book a Rapido, then or Ola cab, get the car immediately, getting into the reach railway station, whatever tariff you need to pay. That means what? No need to buy a car and not need to maintain a car. The same way, instead of buying and maintaining servers, we are gonna be getting servers, and based on usage, we're gonna be pay rent. Any cloud is a rental based infrastructure only. But which cloud we're gonna be learning? AWS, Amazon Web Services. Amazon Web Services. So Google is there, Azure is there, AWS is there. These three are leading cloud providers, but we're going to be learning AWS. We're going to be learning AWS, Amazon Web Services. Amazon Web Services. So in AWS, totally we're going to be learning 4 modules: VPC, EC2, RDS, S3. VPC is nothing but a network. EC2 is nothing but a servers. RDS is nothing but database. S3 is nothing but a storage. So please repeat one more time. What is in exactly EC2? EC2 is nothing but what? Server. VPC is nothing but what? Network. RDS is nothing but what? Database. S3 is nothing but what? Storage. So what kind of infrastructure required for deploying our application? Can able to get it from cloud or not? Yes. Yes or no? Yes. But let us understand a little bit deeper what is the VPC. VPC is nothing but a virtual private cloud. So what exactly in your office network, you can able to experience your home network also. The same kind of network, if we can able to get it over internet in virtual form, is nothing but what? VPC. Okay. Anybody can able to getting into the cloud. Anybody can able to getting into the cloud in AWS. Anybody, you and me, anybody can able to getting into the cloud. After getting, you can able to create a network, private section. On top of, we can able to create resources. Based on rules and regulation, we can access from outside world. Like everybody can able to create your own private section. This is my friend's VPC. So that means what I'm trying to tell you, please. So anybody can get, after getting, we can able to create a private section. On top of only, we can able to use cloud. So like example, if you are getting into the Gmail, once if it is getting into the Gmail, can able to read my emails? Can I read your emails? No, not possible. Am I right? The same concept here also. The same, after successfully creating a network, on top of network, we're going to be creating EC2. What is EC2? Elastic Compute Cloud. By helping of EC2, we can able to get a server. Server is just like your laptop, which are all the components available in a laptop. Same components we are going to be using in our server also. But your laptop is just for home purpose, server is for deploying our application like a website. So see here. So these are all the components available in your laptop also, am I right? But by using the same components, we can able to create a server. Server is just like your laptop. So let us understand with an example. Let's say I want to deploy a Netflix kind of application. So what is the required first? First thing is what? VPC, virtual private network. Then EC2. So first we need to create a network. On top of server we created, on top of we deploying Netflix application, we can access this way, this way. But what about customer information? What about customer information, login information, where exactly we can maintain in a database, in a database. RDS, relational database services. By using RDS, we can able to get any kind of database like MySQL, Oracle, anything. So customer data we can maintain here. But why we are using? Okay, so network is there, server is there, data, customer data is there. But why we are using Netflix? For browsing web series, movies, web sessions, whatever maybe. But if it is a Blu-ray printed movie, how much size it is? Around 3 GB to 16 GB. So can able to inserting into this database? No. That's what we're gonna be using an external storage, simple storage service. So by using AWS, what kind of infrastructure we require, we can get it. On top of this infrastructure, we're easily deploying our application by using DevOps process. So we are using DevOps process for deploying our applications on production service. While we're deploying our applications, we are gonna be using AWS. We're going to be getting infrastructure from AWS. I hope you people are understands very clearly what is AWS, what is DevOps, what is the difference between these two also. But let us understand before taking your questions. Overview of this course. This course is complete with DevOps. Complete with DevOps. Complete DevOps, complete AWS, Linux basics and shell script. It is around take 4.5 months. Linux basics will be covered, shell script will be covered. No programming, Java.NET is not required. You require a laptop for daily practice. Freshers can join in this course. Experienced students can. Any graduate can also join. So which are all the benefits? Daily class recording videos after the payment. Via Google Drive, we can access resume preparation, entry question and answers for live real-time projects. 80% of soft materials I'm going to be provided. Our course starts with very basic level, finish with an advanced. Each and every class is a practical implemented in front of you. After completion of course, you will receive a certificate. Daily 1 hour class, 7 a.m. to 7 a.m. to 8 a.m. 7 a.m. to 8 a.m. The classes are Monday to Saturday. You're going to be paying 12,000 rupees for complete DevOps, complete AWS daily recordings. So this is our admin number. Please be contact. This is our content link. If you double click on it, you can able to open a document and you can see my document list and course content, DevOps, AWS, we can see here. So DevOps content, AWS content. I'm going to be shared this information in the chat box. Please be double click on it. Please be double click on it and get it. Any questions, please? All of you. Any questions, please? Any questions? Shall we continue? Course duration is 4.5 months. I already cleared 4.5 months duration. This total duration of this course is what? 4.5 months. Yeah, that's it. Shall we continue by tomorrow? Please be continue by tomorrow. Who are interested, please be do the payment and get the new paid link and continue by tomorrow. Tomorrow onwards, we're going to be start regular sessions and we're going to be start our practical sessions also tomorrow. Thanks a lot. We'll continue by tomorrow. Thank you.